sorry. I'm sorry. This is so embarrassing. I just need a minute. I'm feeling a little emotional because today I'm saying hello to you, but also saying goodbye to Unit 1. That's right, you heard me. We're done with our first unit of Algebra 1. Don't clap, don't cheer, you monster. I'm having a moment. Okay, the moment is over. Enough with the waterworks, Mr. Volel. Of course, no goodbye in algebra is ever really goodbye, because the cumulative nature of our course means everything we've seen thus far will follow us for the remainder of our time together. Not in a scary following us kind of way, of course, but in a comforting following us way, like a puppy that loves us so very much that it just can't bear to be left behind, and you wouldn't leave behind an adorable little algebra puppy, would you? You know what? Don't answer that. I don't want to know. Anyway, before we give Unit 1 its proper send-off, there's one last nit for us to pick in our journey of rearranging equations, this time, part 3. So from last time, remember that we talked about, well, what if I want to solve for a variable that lives in the denominator of a fraction? Well, we came up with a strategy that allowed us to get something in a denominator out of a denominator. What move can I make? What choice can I deploy, in this case, to make this look the way I want it to look? Take 10 seconds, pause the video, remind me, and we'll chat. All right, I'm feeling chatty. Well, in this case, if I want to say get this b in the first equation out of my denominator, well, my move should be to give up. Now, of course, if I want to undo division by b, I should probably multiply by b. So the strategy that we came up last time we chatted, well, if I want to undo division, I should multiply both sides of my equation by that denominator to move it into a place where it's no longer doing some division. So for our first equation here, 3a plus 2 over b equals c. You know what? Actually, give yourself a minute. Pause the video. Take these two equations. See if you can get your desired variable by itself. Pause, play around, see what you come up with, and we'll chat. Are you done? 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 I'm done. 3a plus 2 over b equals c. Well, I want to get this b out of the denominator. Let's multiply both sides of our equation by that b. On the left side, times b divided by b, these undo each other. I'm left with 3a plus 2 equals b times c. And then I just want to get b by itself. Well, let's get rid of that pesky little c. On the right side, c over c goes away. And on the left side, 3a plus 2 over c equals b. I was going to try and make some joke about like the sea disappearing and then like our oceans are disappearing, but actually the oceans are getting larger because of global warming. Anyway, w equals x over y plus z. I want to solve for y. Again, same move here. Even though I have a y plus z, if I want to get a y out of the denominator, I should multiply by that entire denominator as we saw last time. So y plus z here is going to get multiplied on both sides. On the right side, they undo each other. So I get my goal. I no longer have a y in the denominator. I've got w times y plus z on the left, and then just x on the right. Now again, I'm welcome to distribute this w if I want to, but if I multiply by w, I'm going to have to divide by it anyway. To make my life easier, I can divide by that w from the jump. So here, times w divided by w, these go away. I've got y plus z equals x over w. And then the last choice standing between me and y by itself, well, I've got to get rid of this z. To undo plus z, I'll use minus z. They undo each other, and I'm left with y equals x over w minus z. Fantastic. So, if we're thinking strategically, this is one thing that could get in the way of us making our equation look the way we want it to look. But other things that could get in the way of that, there's another issue that we might run into. Think back to when we were solving equations with variables on both sides. To get a variable by itself, I want one copy of the variable. Well, what happens if there's more than one of that variable? So here, I've got hj minus jk equals m. I want to solve for j. The issue here is that I've got 2 copies of j when I want 1. So I need to put my mathematical strategic thinking cap on. What choice could I make here to turn these 2 copies of j into 1? And the hint that I'll give you, j is a common factor, wink, wink, nudge, nudge, of hj and jk. So if j is a common factor, eyebrow raise, what choice could I make to turn these 2 copies of j into something with a single copy of j? Maybe, if I look back at where this might have come from, then this can give me some insight on a choice I could make. Take a risk, take a chance, take a guess. Who cares? What might I do here? Okay. Well, the idea here, maybe if I think about where this came from, well, if I want to turn this into something with a copy of a single j, well, if j is a common factor of both the hj and the jk, I could imagine that there was some distributive property problem from which this expression, I almost said equation, I almost said equation again, expression. I'm good at words, I promise. That's why I teach math. From which this expression came. So, the question that I could ask myself, if I try to reverse the distributive property, what would have needed to be inside of these parentheses so that I would get to hj minus jk? This process actually has a fancy name, the reverse of the distributive property. Sometimes mathematicians like to call this factoring. So to remind myself how to factor out a common factor from 2 terms, let's scroll down. Let's say that I want to factor something like 5x minus 10, or ab minus ac, or 7mn plus m. The question I want to ask myself is, well, what do they have in common? So take a look at each of these. What is the common factor between each of the 2 terms in each of these expressions? What do they share? What could I remove using the reverse of the distributive property? Go. And stop. Well, 5x minus 10. If I'm thinking about the thing that they have in common, well, both of them have a factor of 5. And then there would have needed to be something left in the parentheses. The way that I want to think, like this orange that I've got highlighted down here, a good question to ask myself if I'm ever stuck on factoring, I can always ask, well, what needed to be inside of those parentheses so that when I do my distributive property back out, I get back to where I started. So what needed to be inside of the parentheses over here so that when I do my distributive property, I get back to 5x minus 10? Take 10 seconds, think. What would need to be inside there so that when I do that distributive property, I get back to where I started? Go. Alrighty. Well, if I want to get back to 5x, what would I need to multiply that 5 by? Well, 5 times x would give me 5x. And then the same thing here, to get back to negative 10, what would I need to multiply 5 by? Well, I'd need a negative sign, and then 5 times 2 gives me 10. Real quick, let's check my work and make sure. 5 times x will give me that 5x. 5 times negative 2 will give me that negative 10. Does this make me happy? Well, no, nothing makes me happy. I'm sad. But in the context of this problem, yeah, this makes me pretty happy. AB minus AC, same question. 7mn plus m, same question. What is the thing that they have in common? And then what would need to be inside of the parentheses when you take that out so that when you distribute back in, you get back to where you came from? Give yourself a 1-minute timer. What do they have in common? What's left in the parentheses? And check your work to make sure that you got it right. Go ahead. Alrighty, let's do it. AB minus AC, well, the thing that they have in common, they've both got this A here. And if I think, well, what needed to be inside of the parentheses? To get back to AB, well, I'd need to multiply A by B. To get back to negative AC, I'd need to multiply A by negative C. So let's check and make sure. A times B, well, that's AB. A times negative C, that's negative AC. Are we happy? Again, no, we're never happy. But in the context of the problem, yes, we're happy. 7mn plus m, well, both of them have a common factor of m. When I remove an m from 7mn, what's left over, right? What would I need to multiply m by to get back to 7mn? Well, I need a 7 and an n. To get back from m to m, well, I don't actually need to multiply by anything. So if I end up with a plus m, well, I would need to do m times 1. So in this case, let's check using our distributive property. M times 7n gives me 7 times m times n. I could write it as nm, but usually we write things alphabetically as we've established. M times positive 1 gives me my positive n. And we're happy. Fantastic. Don't know why I wrote that in purple, but it doesn't matter. Scrolling back up, with that in mind, we reminded ourselves how to factor. Let's see. If I factor out a j from hj minus jk, what would need to be left inside of these parentheses here? Take 5 seconds, pause. What needs to be left over? Go. 4, 3, 2, 1. Well, to get back to hj, I would need to multiply j by h. Why am I in green? To get back to negative jk, I would need to multiply by negative k. Very quickly, let's check and make sure. If I distribute j to h, well, I get jh. If I distribute j to negative k, I get negative just kidding. Is that where we started? Heck yeah. Cool. So now, I'm trying to get j by itself. What's the last thing standing between me and an isolated j here? What do I need to do? 4, 3, 2, 1. Well, the thing connected to it is the h minus k. It's connected by multiplication. Let's undo it with division. So we'll divide both sides by our h minus k. On the left side, they cancel out. And I've got j equals m over h minus k. Beautiful. So there's your idea. If I can factor out my common factor, then I can change something with multiple copies of my desired variable into something with just one. Let's do a little more practice. So with this same idea in mind, I've got xy plus xz over v equals w, p equals, I'm not going to read the rest of it. You can read. Let's figure out what choice I want to make to get this to a place where my desired variable appears only once. How can I factor it out from each of these places and put myself in a position where I'm happy? Go ahead, play around, see what you come up with. Give yourself a 2-minute timer. Solve for x, solve for q. Go, go, go. And stop. xy plus xz over v equals w. So again, my strategy here is to factor out my x. So I'm going to take my x, I'm going to give myself some parentheses here. I need to ask myself, well, in this numerator, what would need to be left over in those parentheses so that when I do my distributive property, I get back to where I started? Well, to get from x to xy, I'd need to multiply x by y. To get from x to xz, I'd need to multiply x by z. So I have x parentheses y plus z over v equals w. And now I'm in familiar territory. I want to get x by itself. What's in the way? What's the easiest thing to get rid of first? Well, let's multiply both sides by our v to undo that division by v. I've got x parentheses y plus z equals v times w. And then last choice, well, I've got to get rid of that y plus z. It's connected by multiplication. Let's undo it with division. So I'm left with x on the left side equals vw divided by y plus z. Cool. Same idea. P equals 7q minus qr over 2. So I'm going to factor it out as soon as I see it in the numerator. P equals, so I'm going to take my q. Again, problem is I've got 2 q's. I want to turn it into 1. So I've got parentheses here. What needs to be left over inside those parentheses so that when I distribute back out the q, I get back to 7q minus qr? Well, to get to 7q, I'd need to multiply q by 7. To get to negative qr, I'd need to multiply q by negative r. And then same idea as before. So now I want to get q by itself, reverse order of operations, SAD map. In this case, plus 1 is going to be the easiest thing to get rid of first. So I'll subtract 1 from both sides. On the right side, they undo each other. I've got p minus 1 on the left equals q, parentheses, 7 minus r over 2. Well, now I want to get rid of that 2 next, probably. Let's multiply both sides by 2 to undo it. So I've got 2 parentheses p minus 1. And by the way, you are welcome to distribute here. So I'll even do the distribution, right? 2p minus 1, or 2 parentheses p minus 1 would become 2p minus 2. But your goal in this case is just to get the q by itself. It actually doesn't matter if you do that distributive property. So if you want to leave it undistributed, be my guest. But if it makes you happier, if it makes you feel safer to do the distributive property, don't let me get in your way. Q times 7 minus r. I want to get rid of that times 7 minus r. Let's divide by 7 minus r to do it. In this case, on the right side, they undo each other. And I've got 2p minus 2. Or if I left it undistributed, then I've got 2 parentheses p minus 1 all over 7 minus r equals the q that we wanted by itself. Fantastic. So there's your idea. Factoring is a new skill. Well, not a new skill, but like an old skill that we've dusted off and added back into our toolbox. Sometimes, though, we're going to need to factor, but a couple moves might stand in the way before we can do it. So for example, EF minus H equals FG plus K. I want to solve for F. Look at this, compare it to the problems that we've seen before. How is this different from the problems that I've encountered up until this point? And knowing what that difference is, what choice could I make so that I can make this look the way I want it to look? Think strategically, what options do I have available to me to get this to a place where I can actually use my skill of factoring? Go ahead, tell me what you come up with. And stop. Well, to me, it seems like the issue is that if I want to factor, I need to get the f's in this case on the same side of the equal sign. So what choice could I make to get that to a place where the f's are on the same side of the equal sign? Well, my inverse operations haven't led me astray so far. So let's say that I maybe want to get all of the f's to the left side. So I'll subtract fg from both sides. On the right side, they undo each other. On the left side, I've got EF minus FG minus H equals K. And from here, I'm in familiar territory. So I've got my F's in this case. Let's factor out our F. I would be left in this case, so when I do my distribution, E times F gets me to EF. Negative G times F gets me to negative FG. I've got that negative H still left over, and then that K on the right. I'm trying to get F by itself, so let's get rid of this H next. Reverse order of operations, do my addition subtraction before my multiplication division. I've got F, parentheses, E minus G equals H plus K, or K plus H. Last thing between me and F by itself, let's divide both sides by that E minus G. E minus G. And then on the right side, left side, I can do directions. F is left over. That should be purple. And then on the right side, I've got H plus K over E minus G. Magnificent. And finally, xy minus w equals xz plus u. I want to solve this equation for x. Give yourself a 2-minute timer. Same idea as before. I've got x's on opposite sides of the equal sign. I want to make a choice here so that it's in a position where I can use my skill of factoring to turn those two x's into 1. Go ahead, play around. And for the last time of Unit 1, we'll chat. Okie dokie. Well, again, maybe I want to move everything over to the right. I could move it over to the left. It doesn't matter. I'll move it over here. Let's subtract xz from both sides. I want to get all of my x's on the same side. Ideally, the side is that they like me. Xy minus xz minus w equals u. Same idea over here. I've got 2 x's. I want to turn it into 1x. Well, what would be left over in my parentheses? So when I do my distribution, I get back to xy minus xz. Well, x would need to multiply by y to get to xy. You need to multiply by negative z to get to negative xz. I've got that negative w here equals u. Same moves as before, right? Add w to both sides. Let's do our addition subtraction before we do our multiplication division. On the left side, they cancel out. X parentheses y minus z equals u plus w. Last move here between me and freedom. Let's divide both sides by that y minus z to get x by itself. And when I do, they undo each other. On the left, I've got x equals u plus w over y minus z. I'm gonna get emotional again. We did it! Congratulations, you made it to the end of Unit 1. Oh, give yourselves a big round of applause, a nice little pat on the head. You've earned it. Alrighty, my dears, be nice to yourself, get some well-deserved rest. Or don't, I'm not your dad. These are gonna be the problems, by the way, that we'll start next class with. If you'd like to, feel free to do some work with them on your own. If you don't want to, that's fine too. Again, I have no control over you. You have autonomy. So, sayonara for now. I will see you again in Unit 2.